So welcome to module number 2 of the Licensed Navigator course. This is where the signal called the shots. We're going to dive deep into NFPA 72 to understand detector placement, how to space out the horns and strobes, and to make sure your fire alarm system is compliant and pass the fire department inspection. So by the end of this lesson, you should be able to understand the layout and the devices according to NFPA 72, avoid the most common mistakes when it comes to placing your detectors, whether it be a smoke or heat detector, and also show you how you can document your work so that way it's inspector ready. So that way there's no hiccups or anything like that, no kickbacks, they understand exactly what you're saying. So the 3 chapters we're going to focus on inside NFPA 72 is chapter 10, chapter 17, and chapter 18. Chapter 10 is where we're going to focus on the design and documentation when it comes to the fire alarm system. Chapter 17 is all about the initiating devices, heat detectors, smoke detectors, the placement, how you should place the smoke detectors in a certain type of square foot, same as heat detectors depending on the ceiling height. Lastly, chapter 18 is all about the notification appliance device, the height requirements, and also the space requirements when it comes to speaker strobes or either horns and strobes. As always, to make this easy for you to understand, and so that way it's not a bunch of long, boring codes being spit at you, we have tools, interactive tools, so that way you can use these tools to help you better navigate the code books. If you do end up memorizing some of these codes, then that's great. It's just like Bible verses. You're not going to be able to memorize the whole book, but you will be able to recite verses and chapters as you advance through this program. So some of the key things I want you to take away before we jump into the slide presentation. Chapter 10 makes you responsible for being compliant and making sure your documentation is correct. Chapter 17 defines where every detector should be installed and how you should install the detector. And Chapter 18 governs notification appliance devices, show you exactly the height requirements and also the spacing requirements for the output devices. So let's jump into the slide presentation, download your tools, make sure you keep them handy so that way you can follow along with the module, all right? So let's get straight into it. Start a presentation. Chapter 10 of NFPA 72 is titled The Fundamentals because it defines the mandatory baseline requirements for all fire alarm and emergency communication systems, regardless of building types, size, or technology. This chapter will answer questions like who is responsible, who must be documented, how must the system perform, and what is the lifestyle expectations of the fire alarm system. Inside of chapter 10.4 is the responsibility of the system installer. Fire alarm installer is required for all the fire alarm equipment and it must be listed for fire alarm use. Fire alarm system must be installed in accordance to approved fire alarm plans, manufacturer specification, and also the AHJ requirements, whether that be if you're working for a government client, a municipality, or for the fire department. All circuits must be supervised, tested, and function properly. Each and every smoke detector must be tested, each and every amper switch must be tested, and they all need to be verified back to the central station to make sure that message is correct and the same so that when you sit in the fire department in the exact location. As-built drawings, manuals, and a software password must be turned over to the building owner once the system has been completed, installed, and passed the fire department inspection. Fire alarm installer is legally responsible for the code compliance. You can't just say, I just follow the prints. It's not a valid defense for you to make. If you understand the requirements of a fire alarm system and you're putting devices that don't belong in a place that it needs to be in, then that's for you. You as the fire alarm installer should be pointing out these errors on side of the plans, because a lot of times these engineers don't come to the field, so they don't know what the building structure looks like or what the environment is. Now, as we get into 10.5, that's the documentation requirements. Some of the things you're going to need when you're filing an inspection or if you're filing a job for a fire alarm project, you're going to need the riser diagram, the wiring diagram, which is like the shop drawings. That will include the battery calculations, voltage drop, your device legends and tags. I can show you exactly what shop drawings would look like that you would have to submit once you get a fire alarm project. And this would be after the fact the drawings have been approved by the fire department. Now you will have to prepare shop drawings that have all of this details on it. So give me 1 second. Here's an example of what shop drawings would look like. It would have your scope of work. It will have your title page, which will have your sequence of operation, your device legend tag, your fire alarm wiring list, your general notes, and what's important, definitely your symbol legend, so that way we can identify what these symbols are on top of the plans. Each plan will have a detailed specification of what needs to be installed, the candela rating, the pole it's going to be installed on, exactly where the device is going to go. We have to show all this detail on the fire alarm shop drawings. Here's another level of detail explaining what all of the devices are, the device address, the sequence and how they're gonna run the wire for the horns and strobe, which is gonna be the first one, which is gonna be the second one, which is gonna be the third one. Now, when we come down all the way down here, this is what the one-line riser diagram would look like. You hand this off to the electrician. He will look at this and understand, okay, I need a pipe for the remote annunciator. I need a pipe going out this way for the input devices, and however they branch it off after that is on them. Another pipe to go out for this booster panel, another pipe to go out from this booster panel, and off of these booster panels are going to be whatever these horns and strobes are. This one-line diagram would give the engineer a quick vision of how they should route their cables and piping when it comes to them installing this fire alarm system on whatever project they're on. Down here will be the battery calculations, system calculations, the load, the voltage drop, how many devices are on the system, what's the actual load of the SLC loop. Here would be the battery and booster panel information, what's connected to the booster, how much amps is being drawn from the booster panel, and you will have to do this for each booster panel. And here's the typicals, pretty much of what the system we're using, how to address the pull stations, how to address the remote annunciators, and also the modules. All this level of detail needs to be provided to the installer when you're the fire alarm company. So that's what shop drawings will look like when you get a fire alarm project and you have to submit your submittal package to the GC or the electrician. Now, as we move to 10.6, equipment and performance capability. A fire alarm components must be listed, labeled, and compatible with each other. You can't use a simplex system with an Edwards system. Everything has to match the same manufacturer for all of the fire alarm devices. As we move to 10.7, power supplies, the fire alarm system must have a primary and secondary power source in line with NFPA 70 and the manufacturer specification. Standby current should be 24 hours minimum. The alarm current should be 5 or 15 minutes depending on the system type. 5 minutes for horn strobes, 15 minutes for a voice system. If your batteries can't power the full system load at the time of installation, so you must make sure you have the right size batteries for your fire alarm system. Moving on to 10.8, signal priority and performance. The life safety signal takes precedence over all functions, meaning if there's an alarm signal, that's going to be priority 1 versus a trouble signal, which is priority 2. Trouble signals must also activate within 200 seconds of the fault detection. So soon as a module goes into trouble, a wire is lifted up, within 200 seconds that the fire alarm system should be enunciating some type of trouble. In addition to having like a single trouble, which is an open, if you have a NAC short, other than a trouble open system, if the system faults and go into short, let's say on a NAC circuit, the other circuits should still operate. So that one circuit may not operate, but if you have 2 or 3 other circuits, those other functions should still perform on the fire alarm system. Moving on to 10.10, inspection, testing, and maintenance responsibility. The owner or designated representative is responsible for ensuring the system is inspected, tested, and maintained according to NFPA 72, Chapter 14. A qualified service provider must perform a supervised maintenance and testing. So if you're in New York City, you must have at least your F95, your F98, and at least minimum NICET level 1 in order for you to be a qualified service provider to perform these functions on a fire alarm system. You must maintain documentation of your testing and make sure you fill out the documentation correctly. If there's any impairments, you must let the building owner, whomever you checked in with, that there are impairments to the fire alarm system, or you will bring that information back to the office so they can let the customer know within 24 hours. So let's get into 10.4, system design requirements. To understand the design responsibilities, performance criteria, and required documentation for the fire alarm system under Section 10.4 of NFPA 72, this section governs how a system is planned, validated, and accepted by the authority having jurisdiction. So what is Section 10.4? It outlines the design level expectations for the fire alarm and emergency communication system. It places responsibility squarely on the designer, installer, and owner to ensure the system meet the fire protection goals of the building, function as intended under all conditions, comply with all applicable codes and standards. This is where you have to bring everything together to make sure that fire alarm system is 100% installed and working perfectly. 10.4.1, the system designer is responsible for ensuring the layout, calculations, and system type, ensuring that they both meet the prospective codes requirements and a performance objective set by the AHJ. You must have the right occupancy type, the type building, the building construction type, the fire risk profile, and the code mandated detection for that particular building. Moving to 10.4.2, compliance with other codes. Sometimes the design may not only align with NFPA, but also NFPA 70, NFPA 101, IBC, and the local amendments from the AHJ. So you must get familiar with other codes and standards throughout the NFPA chapters, throughout the NFPA series of books to ensure the system is designed according to those specifications. 10.4.3, component compatibility. All components must be listed for fire alarm use compatible with each other. We cannot mix manufacturers with manufacturers. Everything has to be the same. 10.4.4, the system must be designed with survivability in mind, including the pathway, the type of wiring you'll run, if it's going to be a Class A or Class B system, the redundant routing or physical protection, and monitoring and supervision of all the supervised circuits. Moving to 10.4.5, design drawings and documentation. The designer must prepare and provide riser diagrams, the wiring diagram, the matrix or narrative of operation, which is the sequence of operation, floor plans with device layout, voltage drop and battery calculations, and manufacturer's data sheet. All of these documents must be submitted to the AHJ or the fire department whom you're getting your approval from and review before you can begin the fire alarm installation. 10.4.6 is your record of completion. A signed and date record of completion must be submitted at the end of each installation, certifying the system was installed by the approved design, was tested and verified, includes all the as-built and documentation. This is your legal receipt that you've delivered a code-compliant fire alarm system that was designed by the engineer and approved by the fire department. So why does 10.4 matter? When a fire alarm system is being designed, it's being designed to be deliverable with a reliable life safety system that will operate flawlessly in any emergency condition. This is the reason why we need to make sure we install fire alarm systems correctly, so that way we can enunciate when it's an emergency, and we can save the building from burning down, keep the fire department there. So as we move into the next chapter, chapter 17, we're going to be talking about initiating devices. I want you to understand the requirements, the performance standards, placements, and application of initiating devices using the fire alarm system, including smoke detectors, heat detectors, duct detectors, water flows, and manual pull stations. So what are initiating devices? An initiating device detects a change in the environment and a signal from the fire alarm control panel to activate the system. They are the first in the line of defense in any fire detection strategy. Chapter 17 defines the types of initiating devices, how they're used, where they're installed, and the response characteristics that you must meet under NFPA 72. Chapter 17.7, smoke detectors detect aerosols and particles produced by combustion. It must be listed for fire detection with defined sensitivity ranges. Ionization smoke detectors are not used in today's technologies, but we do have photoelectric smoke detectors that's definitely better for smoldering fires. Then they have multi-criteria smoke detectors, which combines a couple different technologies together, like heat, smoke, and also gas detection in one particular device. There's placement rules in NFPA 72, chapter 17.7.4. You must keep them 3 feet away from air diffusers or return vents. If you're going to mount the detectors on a wall, they must be 4 to 6 inches down from the ceiling. And if you're going to mount them on a ceiling, they must be 4 inches or a foot away from the wall. But you will use the 0.7 rule if you're mounting smoke detectors on the ceiling. And that will be figured out with the calculations done by the engineer. 17.6 talks about heat detectors. Respond to temperature rise, like fixed temperature or radarized smoke detectors, is used in areas where smoke detectors are prone to false alarms, like kitchens, mechanical rooms, and also parking garages. The spacing for heat detectors is 50 feet, as the spacing for smoke detectors is 30 feet, using still the 0.7 rule. Moving to 17.13, manual fire alarm boxes, which is known as pull stations. It allows occupants to manually initiate a fire alarm. They must be readily accessible, unobstructed, and installed no higher than 48 inches above the finished floor. It's actually between 48 and 54 inches to the actuator above the finished floor. And the actuator is the lever that you pull to initiate the fire alarm manual pull station. It must be within 5 feet of all exit doors, and all exit doors in other approved locations must have a pull station. So every stairwell, entry doors, if you have a entry door that's larger than 40 feet, you will need a pull station on both sides. 17.12, water flow detection. A water flow is installed on the sprinkler pipes. Is to monitor the flow of water. So if there's water flowing through the pipes, there's a flapper on it that's connected to a relay. So when the water is flowing, that flapper will lift up, causing the relay to close for a predetermined amount of time, which is anywhere between 40 and 90 seconds. If the water is flowing within that predetermined amount of time, then the water flow will activate. Water flow device is non-silenceable, so you cannot silence the water flow. You would have to silence the water flow device itself, meaning you would have to reset that water flow, stop the water from flowing, and get that switch to open up in order for you to reset the system. Moving to 17.8, where we're talking about beam detectors and linear heat detections. It's ideal for large and open spaces like warehouses and atriums. A beam detector reflects a light that looks directly into the reflector. How a beam detector works is if there's any obscuration that get into that room that's gonna obscure the light between the light and the reflector. So if you block that light, that is what would put the beam detector in alarm. Moving to 17.10, duct detectors. It's required for air handling units, 2,000 CFMs or more. If you don't know if the fan is 2,000 CFMs or more, you would have to ask the GC, your project manager, or even the AC guy who's out there installing the AC detector, who's out there installing the AC units. You would also put duct detectors on a return fan if it's serving 2 floors and it's more than 15,000 CFM. So if you have an air handling unit that's 2,000 CFMs or more, you will have to install the duct detector. And you will have to also install a remote test switch at least 3 feet away from that duct detector to give us or whomever the indication that there's a duct detector in this area. That duct detector must also initiate fan shutdown through the programming, whichever system you're on. That relay should actually activate to shut the fans down. So some of the performance and supervision requirements. All initiating circuits must be monitored for integrity, open, shorts, or ground. Whatever the change of state is, that system or that circuit will notify the fire alarm control panel. All devices must be listed, labeled, and installed according to the manufacturer's specification. If any device activate or go into alarm, an audible and visual alert must happen. So if the alarm go off by a smoke detector, water flow, a heat detector, whichever input device that activates the alarm system, it must sound the alarm, audible and visual. And you must also send a signal to the central station monitoring company of that particular alarm event. So as we get into NFPA 72 section 17.7, smoke detector placement, spacing, and location. To master the correct methods for placing and spacing smoke detectors based on ceiling geometry, airflow, environment, and occupancy type, ensuring reliable fire detection and compliance with NFPA 72 section 17.7. 17.7 outlines the rules and guidelines for installing spot-type smoke detectors, including on the ceiling and wall-mounted detectors, within different environmental considerations, the expectations of the system and how it should perform, and also how to calculate the spacing between each detector. Chapter 17.7.3.2.1 is referring to standard ceiling spacing. On a smooth ceiling, the maximum allowable spacing is 30 feet between each detector. This provides coverage up to 900 square feet per detector. So if you have a 30 by 30 grid layout, if any ceiling exceeds 900 square feet without a detector, it's definitely out of compliance and it's out of code. This is if you're mounting the smoke detector on the ceiling. So it should be no more than 4 inches to 12 inches from that wall. If you think about it like this, within that corner of the ceiling, and if there's smoke that's filling up the room, in that particular corner, it will not be enough smoke in that 4-inch box or that 4-inch triangle for the detector to get enough obscuration in there to go off and set the alarm off. That's why we have to move it back at least 4 inches, no more than a foot, so that way enough smoke can actually get into that smoke detector, sound the alarm to get the people out the building and get the fire department there to put out that fire. Now, wall-mounted detectors. Wall-mounted detectors must also be between 4 inches and 12 inches down from the ceiling. The same rules apply when it comes to the smoke filling up that particular room. And that corner is not going to be as much smoke as it is a foot away from that corner. Moving on to 17.7.4, the environmental factors. Smoke detectors must not be installed within 3 feet of any supply air diffusers or return vents. This is going to blow too much dirt particles, too much wind, too much anything onto the smoke detector constantly that will get this detector either going maintenance fault, stop working, or to either be a nuisance alarm and always false and go into alarm. Moving to 17.7.3.2.3.1, obstructed ceiling spaces. If your ceiling is obstructed like with beams or soffits, you must apply reduced spacing rules. Detectors must be installed in every beam pocket if the beam depth is greater than 10% of the ceiling height. I usually go by 18-inch rule. If the beam is more than 18 inches, you need a smoke detector in every pocket. For ceilings above 10 feet, smoke stratification and slower buildup times must be considered. While NFPA 72 doesn't prescribe a specific rating, manufacturer recommendation and engineer calculations must be used to justify the spacing. In New York City, the AHJ must require reduced spacing or use any beam detectors in high ceiling warehouses or atriums. In New York City, the fire department will require reduced spacing or the use of beam detectors in high ceilings inside of warehouses or inside of atriums. Slope ceiling, 17.7.3.2.4. Detectors must be installed within 3 feet of the peak measured horizontally. Spacing must be adjusted using the horizontal projection of the ceiling. If you think of it like this, on a sloped ceiling, smoke rises to the highest point. Flat spacing rule doesn't apply, so reposition or the angle of the smoke detectors are how you install it. Smoke detectors must be installed in each pocket depth is greater than 10% of the ceiling height. Pocket area exceeds 900 square feet. Pockets under these thresholds may be covered by adjacent detectors but must be justified with documentation. Always use a laser distance meter when measuring ceiling height and spacing, so don't eyeball it. Make sure you're using a tool that's giving you the exact spacing. So moving on to Chapter 18, Notification Appliance Circuits. To understand the requirements for selecting, placing, and configuring audible and visible notification appliance in the fire alarm system in accordance with NFPA 72 Chapter 18. This includes horns, strobes, speakers, and combination devices used for notifications. Notification appliances are output devices used to alert building occupants for a fire or emergency condition. They fall into 2 main categories: audible appliances, horns, bells, chimes, and speakers, and then we have visual appliances, which is strobes and visual indicators. Then there's combination devices where we have horn strobes and speaker strobes. There are also chime strobes as well. So in Chapter 18.4.3 speaks about the sound pressure requirements. In the public, you must produce a minimum of 15 decibels above the average ambient sound level, 5 decibels above the maximum ambient level lasting at least 60 seconds. Minimum sound level is 75 decibels at the pillow. When you're sleeping, it's minimum 75 decibels at the pillow level when you're measuring the sound level. So if you're inside a commercial space and the average ambient sound is 50 decibels, the horn strobe must deliver at least 65 decibels so that way you're able to hear. Next is Chapter 18.4.2.1, Temporal Pattern. Fire alarm horns must sound a standard temporal 3-pulse pattern, often called a code 3. This would be used with coded systems. You will see on the pull station, it would be like a 141. So if that pull station activates, it will spit out a coded pattern, 1, then a 4, then a 1. There will be a pause in between each one. So that way you can identify quickly, if you know it, oh, that's the pull station, 2nd floor, stair B. Chapter 18.5 speaks about visible notification appliances. Strobes are rated in candela, a measurement of light intensity. So some of the values are 15, 30, 75, and 110 candela. That is the flash intensity for a person who may be blind, but they can still feel the pulse if the fire alarm system is actually flashing. So some of the standard values for the candela rating is 15, 30, 75, and a high candela rating is 110 and more. The required candela rating depends on the room size, the ceiling height, the mounting location, and also the viewing angle. So all of these factors must come into place when you're actually figuring out what type of candela rating you need to use when you're setting up the strobes. Chapter 18.5.5.4.3 speaks about synchronization. Multiple strobes in the same field of view must flash in unison. You may need to install a sync module, but some of the newer devices do work 2-wire and they all can sync if they come straight off the same power supply. This is required by the ADA compliance. Unsynchronized strobes can trigger seizures and confusion, so all of the strobes must sync in unison. Over into chapter 18.4.4 and 24.4, this is for voice evacuation. This is used for large occupancies like high rises, school, assembly places, colleges and dorms, large assembly places like that. Speakers will broadcast a pre-recorded voice message in addition to the tones. The tones is the alert tones that will play over the speakers to let you know that someone is making an announcement. This also must comply with Chapter 24 in addition to Chapter 18 NFPA 72. Chapter 18.5.3.4.1 deals with ceiling-mounted strobes. Ceiling strobes must be mounted in the center at all possible whenever you're mounting your ceiling strobes, your ceiling speaker strobes, or your ceiling horn strobes. A wall-mounted horn strobe must be mounted between 80 and 96 inches to the center or to the light above the finished floor. Chapter 18.5.5.3 and 18.4.5.3 speaks about sleeping areas. They must include high-intensity horn strobes, 110 candela minimum. Low-frequency sound is at 520 hertz. This is required for dorms, assisted living, and apartment units when required by the code. So you will have to use low-frequency sounder bases or low-frequency horn strobes while people are sleeping, so that way you're not scaring them when they wake up. Restrooms and public spaces. Small rooms do not require a separate strobe if its adjacent space is visible, meaning if I can see the other side and I can see the strobe down the hall, I don't need to put another strobe in there because I can visually see the next one that's there. So 18.6.5 talks about the room coverage and candela rating. Here we have a typical diagram of what a 20 by 20 room, 30 by 30, or 40 by 40, what type of candela rating should be set for that particular strobe in a room that size. So that is the end of module 2. I catch you in module 3 where we command control. This is where we learn about HVACs, elevator shutdown, fan shutdowns, and all those different functions when it comes to the output activation. All right, I'll catch you in the next one. Peace.